In this video, we'll talk about surface area on more of a conceptual level as opposed to the typical formalized approach of things. So when we talk about surface area is a concept that historically is very misunderstood, and I think part of that stems from how it is taught, at least historically. From a historical perspective, you'd be given a solid, and a solid would be like a prism or a pyramid or a sphere, any kind of three-dimensional figure. And for each and every one of those, there's a different formula. So there is some logic into saying, well, if you can match the figure with its formula, then you can find the surface area, but some of the meaning is lost. So in this video, we're going to really talk about what surface area means. So we've talked about area, and we've talked about volume. So area, in a two-dimensional sense, is the amount of space something would take up on a plane. And remember that a plane is a totally flat surface, like a coordinate grid, or just maybe one side of a figure. So we're just looking at potentially this red side, and that's it, just that particular slice. And then what we would do for surface area is we're taking this idea and we're saying, okay, well, if we look at a three-dimensional object and we look at each particular face, and keep in mind that these things that I'm shading are what we call faces. So there's this red face, there's a blue face, and there's a face that is behind that. So this backside, and then we also have a top face, this triangle here, and then a bottom face, which would also be a triangle in the case of a prism. So the idea is we're going to find the area of each face of this object, and then we're going to add them up. So in essence, we're asking, okay, if we were to press all these faces totally flat, how much space would it take on a coordinate plane? Now, another way to think about this, another analogy here, would be to think of surface area as if I wanted to paint this prism, how much paint would I need? How much area would I need to cover? Kind of thing. Whereas volume, we're more worried about capacity. How much can this thing hold? How much space does it take up in a three-dimensional sense? And I think the issue with surface area from a historical perspective is that you're blending this two-dimensional idea with this three-dimensional object. And the idea is we're looking at how much space does each face represent. And remember that each face is in theory a two-dimensional object. So now that we've talked about the theory, let's talk about an example of how to calculate surface area. So in this case, let's look at a triangular prism laying on its side, and we've been given some measurements. So for starters, let's look at the triangle. I'll do that in green. Now, since we know this is a prism, we have essentially two of these. So we'll have like this front face that we're looking at, and then the back face is also going to be the same. So once I find one, I can just double it and I'll have both. So I'm going to try and figure out what the area of this triangle would be. So this would be the base of my triangle would be 5. So we know that the area of the triangle is equal to 1/2 times the base of the triangle, which is 5, times the height of the triangle, which is this 2.5 number. Okay, so we'd go through here and we would figure out that the area is equal to 2.5 times 2.5, which is, I do believe, 6.25. And in this case, we'd be looking at inches squared. Because it is an area, we use square units. Okay, so that would tell me the area of one of those faces. So then I would double it when I'm ultimately doing the surface area calculation, because there's two faces that are those triangles. So I have two of these. Okay, now let's look at the rectangles. Now, since this is an equilateral triangle on the basis, or on the triangular base of the prism, we can just figure out one of the rectangles and multiply it by 3. So if we're looking at the 7 inches in length, and each rectangular face is 5 inches in height, then we can say the area of just one of these is going to equal 5 times 7, which we know that to be 35. And again, we're looking at inches squared. Now we know we have 3 of these. So ultimately, our surface area is going to be 2 times 6.25 plus 3 times 35. Because we have 3 rectangles, that's where the 3 times the 35 comes from, and then we have 2 triangles that are each 6.25 square inches in terms of area. So we would add these up, and we would have our surface area would equal 12.5 plus, let's see, that'd be 115. And if we add that up, we would have, let's see, looks to me like 123.5 square inches. And that would be our surface area. So the idea is you're going to find the area of each face and add them up. Now sometimes you may have different rectangular faces because we may not be dealing with an equilateral triangle, or you may be dealing with a rectangular prism, in which case you may have a couple different cases. But just think about the area of each face individually, and then you're not going to get lost in which formula do I use, which one do I not use.